Good day po everyone. We are the Quadro Arcon. We are here to report the topic about solar power home. So our group is composed of Kurt Angelo Tarlit, Jose Gaspar Papa, Alexius Troy Asarcon, and lastly Mr. Kyle Gulag. So first and foremost, let's talk about what is solar power home. So a solar power home refers to as a household that has a rooftop photovoltaic or PV array or ground mount solar system installed in order to generate usable electricity from the sun. So in layman's term, it is using the energy from the sun to convert it into an electrical energy. So there are three configurations of solar power home. So first, let's talk about the grid tie solar power system. So a grid tie solar is by far the most cost-effective way to go solar. So because batteries are the most expensive component of any solar system, but grid tie solar owners can skip them completely. So how do grid tie solar power systems work? So first, let's define what we mean by the grid. So the grid is the utility company's network of equipment that brings electricity from the power plant to your home or commercial building. If a building is getting electricity from the power company, it is connected to the grid. So a grid tie solar systems can sense the energy they generate into the grid, where it is stored for later use. So under a net metering agreement, the system owner receives a credit for anything they generate, and they can make use of that energy at any time. So in grid tie solar system, while generating energy, you can also generate some income if you apply under the net metering agreement. So what are the advantages of grid tie solar power system? A grid tie solar is the best option if you want to offset your electricity bill and save money over the life of your system. Most grid tie systems pay for themselves within 5 to 10 years, with solar panels warranted for 25 years. Grid tie solar is the only option that reliability turns into a profit for the system owner over the life of the panel. Another advantage is that grid tie systems can be smaller. You don't have to generate 100% of your power each month. The grid can supply additional power beyond your production, which is useful when bad weather happens. The output of your panels. So for example, some people choose to size a grid tie system for a partial offset of their bill, with plans to expand the system later once their budget allows for it. Design requirements are less demanding than in an off-grid environment, where you are fully responsible for your energy needs. So let's now talk about the disadvantages of grid tie solar power system. The main disadvantage of grid tie system is that they are still vulnerable to power outages. But wait, you might say, if I'm generating power from the sunlight, why does it matter if the grid is down? So unfortunately, grid tie systems are wired into the utility company's infrastructure. In case of an outage, utility workers need to troubleshoot and fix the problem. And they can't do that if connected solar systems are still energized and feeding power to the grid. For that reason, grid tie solar systems are switched off during outages to allow utility workers to safely make repairs. So what is the solution? A hybrid system that connects to the grid but draws on a battery bank in case of outages. So we'll cover those at the end of this article. So let's talk about the second configuration of solar power system. It is the off-grid solar power system. So it is the best for delivering power to remote locations where there is no access to utility line. It contains large set of battery packs which stores energy during the day to be used at night or at times when sunlight intensity is low. So unlike on-grid, unlike grid tie, in off-grid system, we are using battery. So the advantages of grid tie solar power system. The main draw of grid solar system is the freedom to live wherever you want. It doesn't matter if your property is 100 miles from civilization. If you have sunlight, you have the reliable way to generate power. Although off-grid solar components are more expensive, there can be some hidden financial benefits to living off the grid that can offset those higher costs. Undeveloped plots of land located far off the grid will naturally cost less than a prime grid-tied location. In many cases, the lower land cost do more than enough to offset the higher cost of going solar off the grid. So the disadvantages of this system is that it's pretty simple. The need for battery bank makes off-grid solar significantly more expensive. However, it is often wiser to invest in an off-grid solar system than it is to run a power line to a remote location. While an off-grid system may cost more than the grid-tied system, it is still more frugal than other remote power solutions, like running a new utility line or relying on a gas generator. One way to keep costs down is to use propane appliances where possible to reduce your demand for electricity. Opting for a propane stove, clothes dryer, wall heater, and on-demand water heater means you can get away with a smaller inverter and smaller battery bank. It also helps to stagger electricity usage. For example, running laundry and the dishwasher at different times to reduce your peak power consumption and relieve some of the cost of high energy storage. So lastly, the last configuration for the solar system is the hybrid. A hybrid solar system generates power in the same way as a common grid-tied solar system, but use special hybrid inverters and batteries to store energy for later use. So this ability is to store energy enables most hybrid systems to also operate as a backup power supply during a blackout, similar to a UPS system. So it's an example of a diagram of how a grid-tie system works. So our grid-tie inverter is connected to a meter, and the meter is also connected to the utility service. So as the solar panel collects energy from the sun, its DC output will be converted into AC current that will be used as the main energy used for the home. So a grid-tied solar power home parts. So let's talk about the parts of a grid-tied solar power home. So first one is a solar panel. Next one is a grid-tied inverter. It also comes with with or without filter. Also a square wave or pure sine wave. So a DC circuit breaker, a DC surge protective device, an AC circuit breaker, an AC surge protective device, a time delay switch, DC or AC electrical wires, MC4 connectors, solar rail, and clamps. So let's talk about the first part of the solar power system. A solar panel, a component of a photovoltaic system that is made out of a series of photovoltaic cells arranged to generate electricity using sunlight. So the main component of a solar panel is a solar cell, which converts the sun's energy to a usable electrical energy. The most common form of solar panel involve crystalline silicon type solar cells. These solar cells are formed using layers of elemental silicon and elements such as phosphorus and boron. The elements added to the silicon layers form an N-type layer which has an excess of electron, and the P-type layer which has a deficit of electron. So these two layers form a PN junction. So here's an image of a solar panel. This picture is an example of a monocrystalline solar panel. So there are two types of solar panel. First one is a monocrystalline solar cell. They are more efficient because they are cut from a single source of silicon. Unlike polycrystalline solar cell, they are blended from multiple silicon sources and are slightly less efficient. They have thin film technology. They cost less than mono or poly panels, but it's also less. So a monocrystalline is black and white in color, while the polycrystalline is blue and white. So the next reporter will now be done. That's what.
So the next slide is inverters. An inverter is one of the most important pieces of equipment in the solar energy system. It is a device that converts direct current, electricity, which is what a solar panel generates, to alternating current, electricity, which the electrical grid uses. In DC, electricity is maintained at constant voltage in one direction. In AC, electricity flows in both directions in the circuits as the voltage changes from positive to negative. Inverters are just one example of a class of devices called power electronics that regulate the flow of electrical power. Inverter regulate the flow. Isa sa mga purpose ng inverter is to regulate the flow ng electrical power. Tsaka nagsisilbi siya bilang emergency backup when power outage. Next slide is grid services and inverters. Grid operators manage electricity supply and demand on the electricity system by providing a range of grid services. Grid services are activities grid operators perform to maintain system-wide balance and manage electricity transmission better. When the grid stops behaving as expected, like when there are deviations in voltage or frequency, smart inverters can respond in various ways. In general, the standard for small inverters, such as those attached to a household solar system, is to remain on during or ride through the small disruptions in voltage or frequency, and if the disruption lasts for a long time or is larger than normal, they will disconnect themselves from the grid and shut down. Frequency response is especially important because a drop in frequency is associated with generation being knocked offline unexpectedly. In response to a change in frequency, inverters are configured to change their power output to restore the standard frequency. Inverter-based resources might also respond to signals from an operator to change their power output as other supply and demand on the electrical system fluctuates. A grid system known as automatic generation control. In order to provide grid services, inverters need to have sources of power that they control. They could be either generation, such as a solar panel that is currently producing electricity, or storage, like battery system that can be used to provide power that was previously stored. So, ito yung itsura ng inverters. Next is pure versus modified sine wave inverters. What the difference? There are two main differences between a pure and modified sine wave inverters. Efficiency and cost. Pure sine wave inverters are good at two things: efficiently power devices that use AC, and powering devices like radios that can suffer from interference. But they can be expensive. On the other hand, a modified sine wave inverter will reduce some interference, resulting in a less than pure current, but they are less expensive than their pure sine counterparts. So, it is what look like. Ito yung itsura ng pure sine wave at modified sine wave inverters. yung sine wave na paalon is ito yung tinatawag na pure sine wave, tsaka yung paliko-liko is yung modified sine wave. Next is DC circuit breaker. DC circuit breakers refers to circuit breakers used in DC power distribution systems from overcurrent and potential hazards. They perform the following functions: interrupt the flow of current when it exceeds a predefined threshold, protect electrical components from damage caused by expensive current, prevent electrical fires and other safety hazards that can result from overcurrent condition. Generally applicable to solar photovoltaic power generation and power distribution systems, battery energy storage systems, new energy vehicle, DC charging systems, etc. A system in which the input power supply terminal of the circuit breaker is DC current. General DC circuit breakers include DC MCB or miniature circuit breaker, DC MCCB or DC molded case circuit breaker, and Type B RCD or residual current device. So ito yung itsura ng DC circuit breaker. So next is yung AC circuit breaker or RCBO type. A residual current operated circuit breaker or RCBO is a critical safety measure when protecting electrical circuits. The RCBO is current sensing component that can automatically disconnect and measure the circuit whenever the current exceeds the rated sensitivity or a fault happens in a connected circuit. This device is purposed to protect one from the risk of electrical shocks, fires and electrocution. It can also assist in sudden earth faults. The installation of an RCBO ensures that the circuit trips immediately and protects you from electric shock. After knowing the RCBO meaning, you can continue to read these articles to cover more regarding the principle and the advantage. So it is what AC circuit breaker or RCBO looks like. So next is DC surge protection device or SPD. A DC surge protection device is a type of protective device used in the solar PV system. The primary functions of a DC surge protection device is to protect the solar system from damage caused by sudden changes in voltage and current. It also protects against lightning strikes that might cause damage through the grounding wire or other paths. A DC surge protection device is a device that protects against the effects of voltage surge in direct current or DC power system. A DC surge protection device is typically used to protect sensitive equipment from damage caused by this voltage surge. A DC surge protection device can be placed in an electrical outlet or on the power cord of an appliance to protect it from voltage surge, or it can be installed at the point where electricity enters your home to protect all the devices on that circuit. Solar DC surge protector can also protect sensitive electronic devices in the installing, such as computers, monitors, household appliances, and safety pathways like fire alarm systems and lightning control. So this is DC surge protection device looks like. The next is AC surge protection device or SPD. The AC SPD are placed parallel to the AC CV. Just like the DC SPD, this serves as protection against transient voltage. But this time, on the AC side of the PV system, SPD redirect this excess power to the ground. Multiple equipment connection on the grid, either internal or external, can be also cause of electrical anomalies where power surge could also arise. So this is what AC surge protection device. Next is time delay switch. A time delay switch or TDS is a switch which is linked to a timer, allowing the user to delay on or off cycles of the switch. There are a number of different styles of delay switch available for the variety of applications, and many are very easy to configure so that users can get the switch to do exactly what they need it to. Hardware stores, home supply stores, and electronics stores typically sell time delay switches along with useful accessories. A time delay switch or TDS is switch which is linked to a timer, allowing the user to delay on or off cycles of the switch. There are a number of different in the most basic form. A time delay switch is a switch linked to a timer which can be set by a user. When the user activates the switch, the timer goes into effect, determining when the light or appliance should be cycled on and off. In an example of how this type of switch might be used, someone could set up a time delay system on the light of a house prior to application so that the light would turn on and off as though someone was home, deterring criminals. Styles of delay switch available for the variety of applications, and many are very easy to configure so that users can get the switch to exactly that they need it to. Hardware stores or home supply stores and electronics stores typically sell time delay switches along with useful accessories. Yung time delay switch is para siyang isang timer. So ito yung itsura ng time delay switch. And then programmable timer switch. Then grid-tied net metering. What is net metering? Net metering is a billing mechanism that credits solar energy system only for the electricity they add to the grid. For example, if a residential customer has a PV system on their roof, it may generate more electricity than the home uses during daylight hours. If the home is net metered, the electricity meter will run backwards to provide a credit against what electricity is consumed at night or other periods when the home's electricity use exceeds the system output. Consumers are only billed for their net energy use, on average only over 20 to 40% of a solar energy system's output ever goes into the grid, and this exported solar electricity thereby customers' loads. So, is net metering available in the Philippines? So, yes. The rules about net metering were taken effectively in the Philippines on July 24, 2013 under the ERC Resolution 9 Series of 2013. It is available only for the on-grid distribution systems. An on-grid distribution system allows users to power their homes or business through solar panels while the sun is shining. When the renewable sources are not available, electricity from users' local distribution utility will be supplied to meet your needs.
what benefit will I get if I adopt net metering? So, through net metering, you can reduce the amount of electricity you buy from your local GU. The rate of savings will depend on the electricity you generated, which will be equivalent to the DU's retail rate, which consists of generation charges, transmissions, system loss, distributions, subsidies, taxes, and other charges. So, why is there a capacity limit of 100 km under the net metering program? So, net metering as defined under Section 4 of the RE law refers only to a system appropriate for distributed generation, e.g. as defined under the Section 4 of the RE law. This is a small generation entity supplying directly to the distribution grid, and any one of which shall not exceed 100 kilowatts in capacity. So, next is who are qualified to participate in the net metering program. So, the only participant is the DO customers whose credit standing in payment of their electric bills are good, are qualified to participate in the net metering program for renewable energy. So, who are the ideal candidates for net metering? So, according to the DOE, customers with pure energy-related charges will benefit from net metering. Customers whose peak demand of electricity coincides with the availability of the RE resource may also stand to benefit from net metering even if they have demand-related charges, because their RE production can potentially reduce their coincident peak demand for electricity. So, consequences of not applying for net metering. So, in the case that solar power system is being installed and doesn't apply for net metering, any excess energy that is being fed to the grid will be billed to the customer. So, example is when the solar array is rated 5 watts and the load consumption is only 4 kilowatts, the system will have an excess of 1 kilowatts which will be sent to the grid. This excess energy will pass through the meter, hence will be billed to the owner. So, another question. So, is there any other way besides net metering that a customer having a solar power system producing excess energy during the day and yet will not pay for it? So, the answer here is yes. So, this can be achieved by using an inverter with limiter. So, this device limits the power that the system will dissipate. It automatically detects the maximum power that the system can provide without the excess being sent to the grid. So, here are the diagram of the grid-tied circuit. So, here are the example of solar power home grid-tied circuit. So, una, para gumana itong solar, kukonekta mo muna siya sa CB, DC CB, circuit breaker. Susunod sa DC SPD. At lalagyan mo yung konektado sa ground hanggang sa panel board. Tapos yung CB ko, konekta mo sa inverter. Yung naka-DC, susunod, pupunta siya sa yung panel board, kukonekta mo na sa RCBO at saka sa AC SPD. At kukonekta nyo rin siya sa inverter para umana. Ito po example ng grid-tied circuit breaker. So, wire sizing. So, ito yung mga wire types. Ito yung thermoplastic wire, moisture resistant and flame resistant. Makikita nyo dito na siya ay silver with So, next one is the thermoplastic heat resistant wire. So, moisture resistant and flame redundant. Next naman yung thermoplastic high heat resistant, yung nylon coated. Ito ay nakadesign for specific insulation, material, temperature rating, and condition of use suit para sa mga dry and damp location. So ito yun, print tsaka block. Next naman ay yung similar to sa kanina, yung ito naman yung kulay pula, water resistant naman siya. Adding W into the acronym. So, wire types. Photovoltaic solar cables are intended for interconnecting power supplies within renewable energy photovoltaic systems such as solar panel arrays in solar energy farms. So, photovoltaic cables are manufactured in accordance with standard BS-EN 3618 and are suitable for fixed installation, internal and external with fluid or systems, but not for direct real applications. So, ito yung example ng photovoltaic wire. So, makikita nyo dito yung una, yung gauge size 3, number 3, 6, yung 8, 10, 12, 14. Mga size lang ito mga. So, makikita nyo sa table na to yung size ng mga AW or Kemil. Yun ang ibig sabihin ng chart na to.
Ito naman yung example ng wire ampacity. Makikita naman natin dito yung size ng AWG. Yan din yung temperature rating of copper conductors. Paki-screenshot na lang. Next. Ito naman yung example ng table 310.15B2A or ambient temperature correction factors based on 30 degrees Celsius or 86 degrees Fahrenheit. Nakikita naman natin dito yung ambient temperature na merong 10 or less. At yan naman yung ambient temperature din na naka-Fahrenheit. Dito rin yung temperature rating nila. Temperature rating of conductors. Paki-screenshot na lang din. Ito naman yung example ng table 310.15B3C, ambient temperature adjustment for raceways or cables exposed to sunlight on or above rooftops. Ito makikita natin tong distance above roof to bottom of raceway or cable. On roof is 0 to 13 millimeters na may temperature ng 33 degrees Celsius and 60 degrees Fahrenheit. Ito naman yung sa above roof na meron ding 13 millimeters merong 22 degrees Celsius and 40 degrees Fahrenheit. Paki-screenshot na lang din. Ito naman yung example din ng table 310.15B3A adjustment factors for more than 3 current carrying conductors. Nakita natin dito yung number of conductors. Una dito is yung 4 to 6 na merong 80% of values ng table 310.15b16 through table 310.15b19 as adjusted for ambient temperature if necessary. At meron din tayong 7 to 9 na meron din namang 70, and yung 10 to 20 na karoon ng value na 50. So, screenshot na lang din. And next, ito naman yung AWG cross-sectional area and in centimeter. Okay, screenshot na lang. Ito yung sizes and cross-sectional area, weight, and overall diameter. Ito naman yung table 240.6 A, standard AMP ratings for fuses and inverse time circuit breakers. Okay, screenshot na lang. Ito naman yung steps sa PV system conductors sizing. First dito is itong look for the ISC rating of PV cell. And the second one is multiply by 2 safety factors, emergency and continuous duty. Third is refer on table 310.15b16 for the size of wire. Number 4, refer on table 310.15b2a for opacity correction due to ambient temperature more than 30 degrees Celsius. 5 is refer on table 310.15b3c for ambient temperature adjustment due to conductor or wire distance from the roof. And 6th step is refer on table 310.15b3a for adjustment due to more than 3 wires inside the conductor. And 7 is find the adjustment due to voltage drop. And number 8 is last step is the value obtained in the last step will be the basis for the size of wire to be used in the PV system. These are the types of PV cell specs. DC and AC circuit breaker sizing. First thing to consider in sizing a CB or PV system is the ruling in PEC, which states that PV circuit current is continuous. Thereby, the minimum OCPD rating is 125% of the maximum current. PEC 2017 Article 6.90.2.2b and Article 6.90.2.3b. Therefore, in reference to the problem in conductor sizing, on the DC side, the max current is 76 and 23 and 25%, that is 19.0.4 use 20 ACB. On the AC side, since the inverter rating is kilowatts, dividing this by 220 volts, the current will be 4.5 amperes. Multiplied by 125%, that is 5.625 amperes. Use 6 ACB or RCBO. Speed sizing. The rule is simple in sizing of surge protection device. Basically, the UC rating of the speed of the SPD site should match the system voltage or a bit higher. 15% to 25% for SPDs to attain a longer lifespan. Therefore, in reference to the problem in conductor's IC, for the DC side, use SPD with UC rating of 1,100 volts to 120 volts. For the AC side, use SPD with UC rating of 230 volts to 275 volts. SPD and specs. In nominal discharge current, IMAX, maximum discharge current. UC, maximum continuous operating voltage or MCOV. UP, voltage protection rating or VPR, or surge voltage rating SVR or clamping voltage. These are the SPD specs. Zero bill computation. Compute for your monthly average kilowatt per hour. We have 300 kilowatt per hour per month. To convert it to daily usage, 300 kilowatt per hour over month, we should divide it to 30 days because in a single month, we have 30 days in total. So, the equals is 10 kilowatts per day. 10 kilowatts hour per day equals to 10,000 watts per day. In Philippines, peak sun hours is equals to 5 hours per day. For solar array rating, we should divide the watts hour per day that we get. Yung nakuha natin, i-divide natin sa 5 na para makuha natin yung solar array rating natin, which is itong 2,000 watts. For zero bill assurance, itatimes naman natin yung nakuha natin na solar array rating sa 1.1 na nag-i-equal sa 2,200 watts. Para makuha natin yung number of panels, we should divided it to 300 na nag-i-equal sa 7.33, and kailangan natin i-round off ng 8 solar panels. Dapat mas mataas kapag nagkaroon palagi ng remainder para hindi magkulang. And that's all. Thank you for listening.